All right, last page of the test. Let's get at it. In the last video, I kind of butchered some statement about the square root function and the a term of the square root function becoming rise over the square root of run. And I couldn't really do that with this problem because this really is about rates of change compared to something that's just the square root of x, and that's the chain rule in calculus. And I don't think that's an appropriate conversation for us to have right now. So I'm not gonna dive into that. If I did dive into that, and maybe I will, then I've really got to get some numbers on the board so you can see how it works. And just not gonna do that. So we're starting at problem 44, solving an absolute value, writing the inverse of an exponential. Name that tune, another graph to be named. We're beginning to move into trigonometry a little bit. Hopefully we'll do the unit circle within a week's time. Well, got several days off, so maybe a week and a half, we'll be doing some unit circle work. But given two values drawn in standard position, what's the sign of A? Just to get the definitions in front of us again. A quick 10-second, can you name that tune? Solving this problem is fairly new for you, so you're gonna have to see that a bunch of times. I've got a logarithm to evaluate, simplify, center and radius of a circle. I'll show you the shortcuts to them. I'm not sure I want to show them quite yet though, because I don't want you taking them until you fully understand what you're looking at. So we're gonna write that absolute value as a piecewise function. Piecewise function, we're gonna solve it for a value and an inequality. We got another function here that I guess we're graphing. One we're naming, and same thing, we're gonna set this equation to 11 and figure out when it's bigger than 11. Some entry-level questions that we'll expand upon as the term goes on. Name that tune, sketch a logarithm, and well, I don't know if anybody got that right on the test yet. But the numbers speak for themselves, and repetition, hopefully you'll start to figure out what goes where and make some sense of it. We'll solve this equation for 1960, and we'll look at the inverse of this equation as we're solving this. We got another name that tune. We'll name it this time two ways. We'll do it with a sine function and a cosine function. Sine function and cosine. Gonna approximate the element of 9 without a calculator now. Okay, got some numbers I've asked you to memorize. We're starting to work with some negative exponents. Okay, we're just going to build on these questions, and point of inflection, that might have been the easiest problem on the test. Not that I think I saw anybody get it. So I think we better talk about it again. All right, let's have at it. This is a record for me. I think I think this is 3 videos in one day, but wanted to get that answer key out so people can look at it and do some work over the weekend, the long weekend. All right, so let's have at it. So let's solve this for 60. We ended the last video talking about a pattern to get x alone. You get rid of the easiest operation first. You get rid of the multiplication or division next. So multiplying by 2, dividing by 2. Been talking about the inverse of 3 to the x. What's the inverse of 3 to the x? A lot of you have it now. It's log base 3 of x. So I got to make this a log base 3 of 27. And people know that that's a 3. Yeah, you probably could have said that anyway. I got 3 to the something. I got 27 over here. The other way was to set it equal to 3 to the 3 and get this equal to that 3. Okay, but let's just go inverse operations here. We're really trying to stress that at this point. So I'm at 3 and I got a rotator cuff problem. So now I've gotten rid of the 6, the 2, the log, the 3 to the. So I got to multiply by 5, which makes this 15. And then I got to add 4. 19. So we can check our number. It should work. 19 minus 4, 15 divided by 5, 3. 3 to the 3, 27. 27 times 2, 54. 54 plus 6, 60. Okay. So what's the inverse of 5 times 3 to the x? Well, I hope you might have a better chance of getting that now. But then we had a number that we're going to have this equal. I'm calling it x. What's the first step in the inverse in the solving process? Divide by 5. What's the inverse of 3 to the x? the log base 3. Now, to check this, use some number that's easy to work with. It's easier to plug a number in here like 2. 3 squared is 9 times 5 is 45. So a 2 gets us a 45. What's the inverse of a 2 getting you a 45? A 45 getting 2. And everybody in the room is capable of plugging 45 in there, dividing by 5, finding the number 9. And what's the exponent on top of 3 that gets you a 9? A 2. How can we see that 2 more clearly? 9 is 3 to the 2. And I'm looking for the exponential activity on top of 3 in this parentheses. Well, there it is. Name this tune. I see an absolute value. The smallest distance you can travel is 5. And 5 seems to be an important number, so I'll write x minus 5. And I think I need a negative sign here because that's a maximum, not a minimum. And I want 7 units to match up with 5. That now does. I've got the absolute value. I got the V shape. It's going down. So all I have to do is say, how far is it from 7 to negative 9? 16 units. How far is it from 5 to 0? 5 units. There it is. So when I put a 0 in here, I'm really getting the absolute value of 0 minus 5. There's your x2 minus x1 with the operational conversion. But that absolute value makes that negative 5 positive 5. So I hope you would write that as our function. Tell I'm rushing through this a little bit. All right, so we're trying to learn to draw in standard form. These numbers may become negative at some point. Right now, we're just looking at a 3 to 4 ratio of x to y. So I hope we are familiar with the 3, 4, 5 triangle. If not, you got to see the 9, 16, 25 Pythagorean relationship, right? Square root of 25 is 5. I'm looking for the sine of angle A. We're going to use angle A and attach it to the origin as we go forward. And so what is the sine of angle A? 4 over 5. Opposite over hypotenuse. And I just want you hearing that for 20 seconds each day. 4 days in a row. You should have that. Cosine would have been 3 to 5. Tangent would have been 4 to 3. Now we're going to name that tune here. Let's do the exponents first. I see exponential growth. But let's take care of the exponents and get them out of the way. X minus 1909 divided by 100. Now we can concentrate on the y values and ask ourselves, how do I show the reader the number 3? Why don't we write it over here? How do I show 3 to 8? Why don't we write that right there? How do I show 3 to 13? Well, I know it's not 5 units of change. 3 to 13 is 10 units of change. It looks like I have a doubling. Gotta move that down a little. Dun, dun, dun. That's better. So these are differentials. And the right-hand differential divided by the left-hand differential gives us the base, provided that we also know the elapsed time. Okay, so that's how you write that. All I can do is keep showing you and hope that you connect with this and look at the numbers long enough to see where they go, and then we can play with it. All right. X plus 3, square root. Well, I know that starts at negative 3 because the smallest square root you can have is 0. And I know that it goes slowly to the right, increasingly. X minus 3. That's 3 units. Minus 3 is about there, and that's that line. I see one answer. We're going to solve this and get 2. And I'll show you why. Let's start with an equation. Let's say x equals 5. There's an equation. How many solutions? 1. Let's square both sides. How many solutions? 2. Do both solutions work in this equation? No. Minus 5 is a fictitious answer, and we get fictitious answers here because the inverse of a cup shape, vertical cup shape, is a horizontal cup shape, and that's not a function. Okay, so we're going to get an extra answer. But so that we sound really smart, we're going to call it an extraneous solution. Extraneous. How about we just say we get a number that doesn't work? All right, so now how do we do this? We use our algebra skills. What do I have to do to the left side? Get x plus 3 outside. I think I got to square that. I got to square this. And most people made a mistake squaring. Most people said x squared minus 9. Let's see if that's true. Is x minus 3 squared equal to x squared minus 9? Let's put a 5 in here. 5 minus 3 squared, I think, is 4. Let's put a 5 in here. 25 minus 9. Oh, yeah, that's 4. I don't think so. So we've been doing binomial squaring quite a bit. And I hope at some point you say that squared, double the inner product, square the last term. Running out of ink. Go figure. Do I have enough ink to finish? Because I don't see another marker in the room. That would be disappointing. All right, so now we can set it to 0. We've got x squared, take an x away, minus 7x, bring the 3 over, and it looks like I've got plus 6. Well, I see that as x minus 6 times x minus 1. So if we remember the drawing, which I erased, there's only one answer, and it's over here at 6. The other one, at 1, well, I guess I can do a better drawing now. The other one was, there, fictitious, extra answer. 1 doesn't work. Okay, what happens when you put 1 in? You get the square root of 4, which is 2, and 1 minus 3 is negative 2. Almost works. Oh boy. Do I see another marker here somewhere, please? Ah, yes. Hooray. We can continue. Didn't want to stop and have to make another video. All right. So exponential activity on top of m. Why don't I get m alone? M to the 10 over m to the 5 is m to the 5. Oh, good ink. Oh, why don't I get it alone with terms of one exponent? 3 times 5 is 15. And I'm asking the question, log base m is saying m to the what? Equals what's in the parentheses. I think I can solve that. It's 15. All right, so there's a real shortcut to this. This is a 10-second problem. 3 or 4 weeks from now, most of you will take the shortcut. Right now, let's not take the shortcut. But the shortcut is, let me do it myself, 5. So negative 5, and the other one is positive 3, and 25 and through 29, 64 with a radius of 8. Okay, just looking at it. Complete the square. X plus 5 squared. I got to get rid of 25. Complete the square again for the y's. Y minus 3 squared. I got to get rid of the 9. Equals 30. Okay. If I bring the 25 and 9 over, I get 64. And I get a Pythagorean relationship where one side is x plus 5, the other is y minus 3. So x plus 5, y minus 3, and the radius is 8. And if I spin this around an axis, a new axis, this axis is 5 units longer than the x-axis. I get a rotation. I can change this, make it longer. That's got to get shorter. Can do that. And I've got a center now of new axes at negative 5, 3, radius of 8, because there's your 64. There's your x plus 5 squared. There's your y minus 3 squared. Pythagorean relationship. And we take the square roots to find the center. Square root of x plus 5 squared is x plus 5. What makes that a 0? Negative 5. What makes that a 0? 3. What's this squared? 8. Right? That's the area. That's the side length. Looking at Pythagoras. All right. Can I finish this? The old guy's been up since 4. It's now close to 12:30, and I'm running out of gas. So I'm just gonna do these quickly. V shape up. 3, 4 vertex. Zeros on this side. Plug a 0 in, I see 10. If I know that, I also know 6 gets me 10. I'm trying to solve this. Next, I'm gonna write it as a piecewise in a second. I'm trying to find when it hits a height of 20. Okay, and I can do that using slopes, but we're gonna find the second x over here and the first x over here. But before we do it, we're gonna write this as a piecewise function. Well, I see 2 pieces. I'm gonna do the side on the left. That seems to stop at x equals 3. So I think that piece, let's see, move this. And let's move this way. There. So I think this piece is just a line. And I think that line, calling it f of x, I guess. I know that line is from left to right going down. Don't get fooled by that arrow. My y values are getting smaller as I follow from left to right. That is easily written as -2 because of the symmetry. The rates go up on one side, they go down on the other. That looks very much like a line. In fact, why don't we call it a line? Because it's a line. But I only can use that line for x's on that side of 3. Because once I get past 3, I'm going up. So on this side, x is less than 3. And on this side, x is greater than or equal to 3. I don't care which one you put the equal sign with, but it exists. All right, so when does it equal 20? Why don't we use the 2 pieces? We'll talk about shortcuts later. Why don't we use this branch? When does that equal 20? Should be an answer less than 3. Let's find it. Oh, move the 4. This should start to sound like a familiar refrain. -2. That means from the center, 3, I'm actually going back 8 units. So I know I'm going to get a -5 now, because that's what that's telling me. But what's the next step? Add 3. All right, so I have a number line now, and I know that -5 gets me 20. And I know that my center of this is 3. So I could go 8 in that direction, which we'll get when we solve this, equals 20. You'll see a sign change right there. Subtract 4, divide by 2. Yes, now I'm going 8 units to the right of 3, which takes me to 11. That should give me 20. Does it look like it over here? Does it look like this could be -5 for an x value? Does it look like this could be 11? Well, we could plug it in and find out. 11 minus 3 is 8. I've seen that number before. Multiplied by 2 is 16. I've seen that number before. And add 4, yes, that gets me to 20. Okay, so I got my answers. My answer is 2. F of x equals 20. X equals -5 or 11. One or the other gets me 20. Now, what am I bigger than 20? Well, if this is a height of 11, if 11 gives me a height of 20, I think that y value is bigger. I think this y value is bigger. I think these y values are smaller. But I could always do true, false, true by plugging in any number bigger than 11. How about I put in 1,000,000? If you put in 1,000,000 here, take the absolute value, double, and add 4. Do you think you're bigger than 20? I would say true. I know the next one's going to be false and the next one's going to be true because I can see the false is the interval in between. It's these branches that are bigger than 20. So let's try a number though, between -5 and 11. Let's try 0. 0 minus 3. -3, absolute value -3. 3 times 2, 6 plus 4 is 10. Is 10 bigger than 20? Nope. False. And if you pick a number less than -5, you'll see true. I don't know if anybody got this problem right, but let's see if we can have some fun with it. why don't we do our y values first? And I see a y value, 1909. Let's start there. And ask the question, how do I get to 2009? I go up 100. I see a logarithm. Did I leave myself enough room? Maybe not. Doesn't hurt to repeat. I see 1909. I add 100. I think everybody's capable of that. I know this is a log, and I know all of my x values have to be bigger than 3. So the question is, how much bigger is 3 to 8? Well, that's 5 units. And how much bigger is 3 to 18? Now, on the other problem that we did I do it already and erase it? I think I worked with this one already, but I've lost track. Because I think I have an 18 in one problem and a 13 in the other, and the old man's eyesight is giving him trouble. So we got to do the one that's in front of us. So that's a differential of 5, and that's a differential of 15. So that's a base 3 log. All right, but usually I don't do it that way, but I just want to point it out. We're going to get a base 3 log. So, but I hate seeing the number 3 appear more than one place, but it appears to be appearing in more than one place. So x equals 3, I want to say x minus 3. That establishes the vertical asymptote. Just got to make a 0, and you can memorize that early on here, and then we can continue to talk about it till May 15th. So x minus 3. Now, you use x values. So let's put an 8 in here. 8 minus 3 is log 5. I don't know what log 5 is. It's the exponent on, this is a common log. If I left it like that, which is base 10, we haven't even talked about that yet, but right now, just a generic log 5. I got no clue what that is. But how about if I turn it into a 1. There, getting tired, obviously. What's the exponent you put on top of any base to get a 1? 0. And what's 0 times 100? 0 plus 1909. I get what I'm looking for. So I'm going to take 8. I'm going to create a 5, and then I'm going to divide a 5. So I create that number, which gets me this answer with it. And that does. So we've got this established. We've got that established. What do you do with 18? It's an x value. You use it. So we drop an 18 in. 18 minus 3 is 15 over 5. That's base 3. So you put any number in here now, any of those numbers, they should work. And I can see that that is 3 times that. So my next differential is actually 5/3, 2 1/3. Right? Because if I multiply that by 3, I've got that, and I should go down to 1809. Okay, keep that in mind. Now, yes. No, okay. Next problem. Let's graph g of x. Well, first thing I see is 5. And then if I pick the right numbers for x, if I pick the right numbers for x, I should make a jump at 12, and then I should make a jump at 24. And my next jump should be 48. And the preceding jump should be 6. And then 3. Because I got a doubling on top of 5. Let's just keep the 12 and the 24. Okay, what goes with this first number? Well, we want 2 to the 0 and we want 2 to the 1. Well, that's easy. I got a 0 and I got a 1. And if I make this a 0, 2 to the 0 is 1. And 1 times 12 is 1 jump of 12 on top of 5 to 17. And if I put a 1 in, then I get 2 times 12, which is a jump of 24 on top of 5, which is 29. And I have finished that problem. Took me a lot longer to do because I'm talking to you. That's that sketch. And that was one more practice to be able to get there. If you want to get there in anything, practice. What you do in your sports. So when is this thing equal to 11? Well, let's put 11 here and find out. Boy, I think I'm going to subtract 5. I think I'm going to get rid of the multiplication. And 6, where am I? 6 divided by 12 is a half. Okay, now I'm 2 to the x equals a half. I can see my answer is -1, right? But I hope you can also think about the inverse of 2 to the x. And I hope you say log base 2 of 1/2. And there's my -1. So if we put -1 in, 2 to the -1 is a half, because we double. We double in this direction. When we go in this direction, we're cutting things in half. And -1 is to the left of 0. So 1/2 of 12, 6 plus 5 is 11. Great. Now, when are we bigger than 11? So this is a differential of 11, I guess. I've lost track of where I am now. No, it was a height. I wanted a height of 11. So if that was 12, then yes, I've got to cut that in half to get to 11. So when are my y values bigger than 11? Well, adding 12 to 5 certainly is. It certainly looks like this value, -1. Well, I think all of those answers to the computation, any number bigger than -1, seems to work. Name that tune. Let's see if you're getting quick with some of these. I'm just going to name it quickly. There you go. So everything is exactly the same as the equation of a line. It's exactly the same as an equation of a line. So let's get that part. That's what we would do for a linear. Everybody's getting the lines right now. The change in x is 4, but I'm not doing that in the quadratic. The change is 4 squared. That's what I have to cancel in order for the numerics to work. What do I do to get from 7 to -10? I go down 17. Okay, now we're going to sketch this. Well, we just had practice with the log. I'm seeing the number 1900. I'm going up 30, so I'm seeing 1930. Okay, now it's all about the x's. I see x minus 4, so I know my numbers have to be bigger than 4. The inverse of growth and decay assumes there's something that's growing or decaying. If I don't pick a number bigger than 4, I don't have a positive quantity here. Okay, so what numbers do I pick? Well, log base 0, log of 0 is your asymptote. Log of 1 is 0, and that's a great thing to multiply by. And log base b of d gets me 1. And this course is based on the numbers 0 and 1. So what makes a 0 and 1 here? What makes a 0 is 4. What makes a 1? A 5. And if I want a base 3, then it would be nice to get base b of b. Well, I got the base. I think I want that to be a 3. That's 7. And I've got my logarithm. So this is changing by 30 units. And if I change by 3, now I'm going to just leave it so I don't have to do a video again. When I get tired like that, sometimes my brain just starts to skip a beat. Then I'm standing there just going, oh, I got to think about this. Now, let's just keep going. All right, so the inverse. Well, the inverse is, well, let's solve for 1960. Let's solve for this equal to, I'm going to put the 1960 on this side so I have some space. 1960. So how are we going to solve this? I think we're going to subtract 1900. I think we're going to divide by 30. I think we're going to do, what's the inverse of log base 3? 3 to the. Okay, and then I think the last thing I'm going to do is add 4. Sure looks like 13 to me works. So let's put 13 in. 13 minus 4, 9. What do you put on top of a 3 to get a 9? 2. 2 times 30, 60, 1900, 1960. Now, if you paid attention to the inverse operations to get here, this is an output of this function. And we just figured out that to get that output, it took the number 13, I believe. Yes, we just did that. Over here, the inverse is dealing with 1960, and we want to get the answer 13. Well, we got to go backwards here. We just have to follow the steps of solving this equation. Now, what was the first step? First step was plugging this in, but because we're making it a function, we're going to plug it in here, right? What are we going to do? Well, the first thing we did is we subtract 1900. Then we subtracted 30. Divided, right? This is multiplication. We divided by 30. Then we did the inverse of log base 3, which is 3 to the. And then we added 4. Let's drop 1960 in. 60 divided by 3, 2. 3 squared, 9. 9 plus 4, 13. So on this side, dropping 1960 in, which was the answer to one of our equations, and looking at the inverse operations brought us to an answer of 13, whereas on this side, 13 got us 1960. Hope you followed that. We're almost done. Element 9 is asking the question, approximately asking the question, and pretty good approximation, 2.71 to what number gets us 9? And it's got to be near 3, right? Because 2 cubed is 8. It's got to be between 2 and 3. 2 cubed is 8. 3 cubed is 27. And that number is in between, and it looks like it's closer to 2. Let's find it. Well, you got to know some e-values. That's why I gave you a memorization sheet. You need to know that e to the 1.1 is approximately 3. So that means 9 can be written as 3 squared. I can replace the number 3 with e to the 1.1. And if I square that, that means I get approximately 2.2. Yes, it was closer to 2 than 3. Now we'll write this trigonometric equation 2 ways. Once as a sine function, once as a cosine. I think it's easier to realize that sine, remember we had the 3, 4, 5? If I divided by 5, that would be 1, that would be 4/5, and that would be 3/5. I hope my memory is not leaving me right now. So if we attach an angle to the origin, the sine is opposite divided by hypotenuse, 4/5. Okay, but it's a height, right? If I make the hypotenuse 1, then we have a unit circle, and this height becomes the sine function. So we're looking at heights, and heights do what? They get bigger until I hit 90 degrees, which we're starting to talk about in radian measurement, pi over 2. And I think I uploaded the video, what is a radian, for you. Hope you looked at it. If I haven't, let me know, and I will. Okay, so I need this to become the angle pi over 2 in order to hit a max. So I need 2003 to become pi over 2, and then I've got 1 revolution, which is 2 pi. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. I need this to become 15 pi over 2. Why 15 pi over 2? Because I started from pi over 2. So maybe I should write that as pi over 2 plus 14 pi over 2, which is another way of saying 7 pi. 1, 2, 3, 4, 5, 6, 7. Okay, you got to hear this stuff repetitively so it processes. And if we don't have enough time, if we don't say it enough time, and you don't get enough time to process it, you continue sequentially with a gap, and that's going to show up, unfortunately, especially at the calculus level, as a difficulty. So we're having a conversation, a long conversation. So I know that's my change in my angle, right? And isn't change in angle over change in time? And I think I'm giving you years. Just a linear function here. I mean, if I pull that apart like a rope, it becomes a line. And that line is actually the circumference of the circle. If I cut it open, it becomes a line. So your x-axis is the circumference when we're starting to work with trig. All right, saying a lot here. All right, let me just get your two answers and let you look at the numbers, see if you can sort it out. So the most important values in between 50 and 80, I think that's 65 plus 15 takes me to 80. I'm doing a sine function and I'm writing 7 pi. 3.5 revolutions take 17 years. I'm going to make 2003 become pi over 2. And I'm done. We haven't even done the unit circle. Yet you can still write this if you pay attention to it. Now the cosine measures width. And widths are horizontal distances, maximum on the right, 1, minimum on the left, -1. So I want, if I want to write this as a cosine function, I want 2003 to act up as 0 radians. And this is what's usually done in a textbook because it's less writing. But I think it's easier to think about maxes vertically than thinking about maxes horizontally. I think there's a big difference there. And so it really becomes this 65 plus 15 cosine 7 pi over 17. But I don't need to match it to pi over 2. I need to match it to 0. And so these curves are the same, but they differ by 90 degrees. Obviously, you don't have to write that. And this is what's taught in the normal pre-calculus classes. What am I saying, normal? I hope I'm normal. No, I'm not. No, but it's not math. I want to get in this conversation. All right, so x squared, almost done. I feel like I'm going to say that forever. So let's just look at x to the 2 divided by x to the minus 7. Well, x to the minus 7 is 1 over x to the 7th. And that, when you divide by a fraction, you multiply by the reciprocal. So I'll just put a dot there. And the reciprocal of x over 7, 1 over x over 7, is x over 7 over 1. Sure looks like I can move this upstairs into the numerator. Okay, let's look at, well, one of these was a negative. Probably this one, y to the minus 5. Probably miswrote that. All right, so let's look at y to the minus 5 divided by y to the 3. Let's put it over 1. Well, y to the minus 5 is 1 over y to the 5. And division becomes multiplication of the reciprocal. 1 over y to the 3. Well, it sure looks like I can move this and make it positive in the denominator. Well, it sure looks like your answer to this one is x to the 9 over y to the 8. Last problem, on your sheet, I told you what minus b over a does, what minus b over 2a does, and now I'm telling you what minus b over 3a does. Minus b over 3a finds the point of inflection of a cubic. Now, you have not been introduced to this much. You have heard it a few times, but it doesn't mean it didn't go poof. Let's look at this graph. Let's pretend that's me running north. And north is going to be I'll run this way. Okay, so let's say I'm sprinting, which I can't do it. Let's just say I'm speeding up. And then I slow down. Still going north. I'm speeding up. I'm slowing down. Still heading north. Wish I had put that there originally. Okay. Maybe the other one. I'm heading north, slowing down and speeding up. Okay, so I'm going to come into the picture at a certain speed. There we go. Then I'm slowing down, and then I'm speeding up. Still heading north. And we could have slowed down and actually turned around, slowed down again, headed that way. Right? We could have some fun with it. But this is a point of inflection. It's about acceleration. Right? And we get bend when we start talking about acceleration. And we're just starting a discussion here. That's all we're doing. And all I'm saying is you can find this location on a cubic by minus b over 3a. The same way you can find minus b over 2a, the x value of the vertex of a quadratic, the same way that you can find minus b over a is where we get a sign change in a linear function. It's the x-axis, intercept. Right? So each of those numbers gives you immediate information. This one would mean that you have to write ax plus b as a times x plus b over a. Right? That's when you get a 0 minus b over a. So you'd have to show that in factored form. But each of those terms, and b over 4a minus b over 4a tells you something. Minus b over 5a, so on and so forth. I don't have the graphing form for a 7th degree anymore, but I had it on a computer. Blaming Maple up, I just got rid of that. Well, all we needed was minus 9x squared, right? There's your minus b. I have to have the rest of it. Of course, I got rid of it. Do I have it here quickly and easily? Yes, I do. Plus 5x plus 7. Oh, I'm glad I did that because I wanted to show you something else. Okay, so what do I know? Immediately, by just looking at this, I know I'm at 7, 0, 7. I know I'm going up at 5 to 1. And then I know I'm bending downwards. The question is, how much? I'm not sure. Finding the point of inflection is going to tell me. That's going to be very helpful. Okay, and so let's find it. Let's do minus b, 9 over 3 times 3, 9. Looks like I picked an easy number, 1. Let's put 1 in, 3 minus 9 plus 5 plus 7. I'm getting tired. 5 plus 7. So it looks like it's 10, 15 minus 9, 6. Oh, so I have one that only goes down below this by 1 unit. Well, that's pretty nice, actually. So 1 gets us 6. Then it's got to swing back up, the symmetry of it. And so I got a pretty good idea of what my graph looks like. And that's all I asked for at this stage. If I want to know what rate I'm changing at, it doesn't hurt to learn that. It comes from a formula, c minus 3ah squared, very similar to b squared minus 4ac, something to memorize. That's called a quadratic discriminant. Okay, it tells you if your square root is negative, well, you got imaginary roots. If it's a nice perfect square, you can factor the problem. Then you got rational roots. And if it's a number like 17, you got irrational answers. Right? So it gives you information. Why don't we call this the cubic discriminant? It tells you whether you have maxes or mins. Right? So I know that c minus 3ah squared better be negative, or I'm really going to be upset because it's the end of the video and I don't like making mistakes. So let's do c. I already got it written there. C, 5 minus 3 times a, which was 3. H we just found. This is HK, just like graphing form. I'm hoping we can get to the graphing form. If not, no problem. It's not in the textbooks anyway. So, but I think it follows, what we're trying to learn. So what have I got here? H was 1, wasn't it? 1 squared. So I get 5 minus 9, which is negative 4. I'm actually going down at minus 4 units, which means I have the graphing form. I'm not going to belabor the point. I have it in front of me. I got the A. The most important term is 1 cubing, rate of change there, plus 6. That's the same as this, unless I made a mistake, and I don't think I did. All right, because this is not going to affect, this is going to overtake that term quickly and move things in the other direction. But that's where the point of inflection is. Then you can find these maxes and mins easily. So supporting videos on that, completing the cube, go to the cubic playlist. You got to look at how to put cubics in a graphing form. You got to look at the geometry behind it. So if somebody's just tuning in here, that's what you got to do. All right. You all guys tired? Yes, very much so. So I'm just going to shut it down and post this, and everybody's got answers to the, and if I made a mistake, Yasser, you tell me. Appreciate it. All right, ciao.